In this video, we'll try to understand what exactly is this word dependency injection and how can we implement dependency injection by using Unity application block. Now my honest suggestion is, before you go and watch this video of dependency injection, please go and first watch the video of inversion of control. So it's like a prerequisite for this video, because the main concept is inversion of control and dependency injection is one of the techniques to implement inversion of control. So first go and watch the video of inversion of control and then you can continue with this dependency injection video. So what I'll do here is, I'm going to go and start with a very small sample 3-layer architecture project. Okay, a sample code, actually not exactly a full-blown application. I will talk about the problems what is related to that 3-layer architecture and how we can go and solve those issues by using dependency injection. So let me just start with a very simple definition first of dependency injection. Then I will go ahead with coding the simple sample application. Dependency injection is a technique which helps you to inject dependent objects of a class. Means, for example, let's say that you have a class program here, and this class program is using some object like, let's say, customer. Okay, I don't have a customer class at this moment, but let's say that it is using a customer object like this. The dependency injection framework will come and inject this object inside your program class. Okay, so again I'm iterating. Dependency injection is a technique which helps you to inject dependent objects of a class. Okay, so that's a very simple definition to start with, but in order to understand what that sentence means, let me go ahead and create a very simple 3-layer project here, and then we'll talk about what that sentence means. So normally when we say a 3-layer application, is divided into 3 sections, right? One is a user interface, the other one is a business logic, and the last one is a data access layer. Now what I'll do is, in order to keep this application or keep this sample code simple, you can see that I have created a very simple console application here. So our console application will be the UI. Then I will go and create a very simple middle layer here and a simple data access layer. So what I've done is, I have not used a WinForm application or a WPF application, or a ASP.NET Web Form application. Why? Because we will unnecessarily get into button click events and page load events, and we will lose our focus of learning dependency injection. So what I've done is, to keep the focus to learn dependency injection, I have just created my user interface with a very simple console application here. So I have a very simple console application, and let's say this console application actually talks to a middle layer or a business component called as customer object, or a customer class, I'll say rather, and the customer class internally calls to a data access layer. Now in professional applications or enterprise applications, when you create these 3 layers, you normally create in new class projects. So in other words, if you're creating a middle layer, you will say here view solution explorer, and you will go and add a new project, right? So you'll normally go and add a new project here, a class project. If you want to code a data access layer, again you will click on new add project, and you will create a new physical project, and you will put those respective classes in those projects. But at this moment, in order to keep it simple and so that we can see the whole code in one go, I'm going to go and code all those 3 layers inside this same namespace here, customer UI. So I will not be creating new class projects, but I'm going to go and create all those classes inside this same namespace, so that we can see the whole code in one go rather than switching between class projects. Remember, our main intention is to learn dependency injection and not 3-layer architecture. So what I'll do is, I'm going to go and create all of those 3 layers inside this namespace itself. So you can visualize something like this. So this class program is actually your user interface layer, right? And let me go and add a middle layer here. So I'm going to go and add a very simple middle layer here. Let's say a customer class. So I'm going to go and add a customer class. I'll just keep one property here at this moment. Let's say customer name property. Okay, so we are not going to go and code the full-blown customer class here. So here's a customer class with a customer name property, and so this is my middle layer here. And let's say that it also has an add method. So I'm going to say here public void add. So when anybody goes and creates the object of this class and he invokes this add method, it actually goes and invokes the data access layer, right? Great. So I have a user interface here. I have a middle layer here. So I have a UI layer here. I have a middle layer, and let's go and code a simple data access layer here. So let us assume that your customer class is actually calling up a SQL Server data access layer. Let's assume that our backend is SQL Server. We are not going to write any kind of SQL code. We are not going to use data set or data reader, right? Because our main concentration is dependency injection. So, but still, let's say that you have a nice SQL Server data access layer, and this class is responsible to do inserts, updates, and deletes to your database. So this add method goes and inserts into database. So at this moment, I'm not going to write any kind of database code here, but I'll just say console.writeLine SQL Server inserted. Okay, so there it is. And this SQL Server class, this SQL Server data access layer class is used inside this middle layer here. So here I will go and create the object of the data access layer. I'll say data access layer is equal to new SQL Server data access layer, and when anybody calls the add method of the customer, I will internally call the add method of the data access layer. So great. So we have a very simple 3-layer architecture here, 3-layer project here. We have a UI, then we have the middle layer, that is our customer layer, and then we have a data access layer, which is SQL Server data access layer. So in this UI here, developers create the object of customer, right? So customer obj is equal to new customer. They set properties of the customer class. Must be this comes from text box, but at this moment I'll just keep it hard coded, and they call the add method. So they call this middle layer add method. The middle layer add method calls the data access layer of SQL Server, right? So very simple 3-layer architecture here, and this is what is used in most of simple projects what are created, right? So what is the problem with this 3-layer architecture now? Now one of the biggest problem with this 3-layer architecture is tight coupling. Tight coupling means, for example, now you can see here this customer class or this middle layer is actually using the SQL Server data access layer, right? But let's assume that some of your customer demands saying that our application should also support Oracle, right? So what you will do, you will actually go and create a new data access layer here called as the Oracle data access layer, and then you will go and make changes into your customer class. So tight coupling means, when I make change at one place, it actually goes and affects all over your application. Now remember, a good architecture is that architecture, wherein if you make change at one place, it does not go and replicate all over the places. So for example, if I make change in one module, it does not start affecting 10 or 15 modules, right? So that's a good architecture. But in this case, if you see, for example, I added a data access layer here, Oracle data access layer. So what I have to do here now is I have to go and create the object of the Oracle data access layer. So I'll just say here, data access layer, Ora. Sorry for the naming convention, Oracle data access layer. And then depending on conditions, he will actually call. So now these conditions can come from a config file. These conditions can come from some parameter table. So depending on the condition, he will call either the SQL Server data access layer or he will call the Oracle data access layer. Okay, so data access layer Ora dot add. Okay, so these conditions here at this moment I've just set true. Okay, but these conditions can come from config files, it can come from parameter table, and a lot of things. Okay, so these conditions can come from anywhere. Okay, so depending on the condition, he's actually calling up the SQL Server data access layer. So you can see this is SQL Server, or he will call up Oracle, right? So in simple words, this is a tightly coupled architecture, and that's bad, right? Because if I add a new data access layer type, I have to go and change my middle layer. Now remember, changes will happen. Some of the developers think that there shouldn't be any change. No, it is not like that. There should be least changes. Means, for example, rather than changing at 10 places, a good architecture will lead to changes in 2 places. Okay, so changes will happen. It's not that changes will not happen. For example, if you add a delete functionality in your data access layer, you won't get automatically a delete button on the screen, right? So changes will happen. But the point is, how least are those changes, and that is important. So at this moment, we have a tightly coupled architecture. So if you want to move from this tightly coupled architecture to a loosely coupled architecture, the first thing what we need to put here is an interface. An interface, a generic interface of a data access layer, which can point towards either Oracle or either SQL Server. Remember, the core thing for decoupling two layers is always an interface. Okay. So the first step what we have to do here is, let us go ahead and create an interface called as IDAL, and that IDAL will have a method called as add. So let me just go ahead and minimize this middle layer here. So what I'll do is I'll create here an interface. So let me create interface here called as data access layer, which will have a method here called as add. Okay, and this data access layer will be implemented by SQL Server data access layer, and it will also be implemented by Oracle data access layer. Okay, so you can see that I have created a very simple interface here, data access layer, which can point by the virtue of polymorphism to either SQL Server data access layer or to the Oracle data access layer, right? So now that would really minimize my code here. So in other words, what I have to do now here is I have to only create or only point towards data access layer, right? Okay, and then depending on situations, I will either create a SQL Server data access layer, right? Or I will either create a Oracle data access layer. Okay, so I can remove this code from here, and so here the object creation is happening, and here I will call data access layer dot add. Great. So you can see here what I'm doing now is, my customer is actually pointing towards data access layer. And depending on my configuration or my parameterization, whatever I do, it either goes ahead and creates an SQL Server data access layer, or either it goes ahead and creates a Oracle data access layer. So this is happening because of polymorphism. Remember, in polymorphism, the same object can point towards different objects under different conditions. So for example, here, depending on the condition, it is either becoming a SQL Server data access layer, or either it is pointing towards a Oracle data access layer. But now the question is this a decoupled architecture? And the answer is absolutely no. Why? Because you can see we still have a lot of concrete classes referenced in the customer class. So you can see here in this customer class, I'm referencing the SQL Server data access layer, I'm referencing the Oracle data access layer. In other words, tomorrow if somebody goes and adds a new data access layer like MySQL, I have to again go and do the modification of my middle layer, right? So in other words, what has really happened is, probably where we were writing 4 lines of code, it has just been minimized to 2 lines of code. In other words, where I was creating the objects of Oracle and SQL Server, it has just minimized those lines of code. That's it, So actually, still it is not a decoupled architecture. Still, it's a coupled architecture. It's a tightly coupled architecture. Now, if you watch very closely, the reason why the current architecture is tightly coupled is, or why the customer class is tightly coupled with the data access layer, is because of this new keyword. Because this middle layer or the customer class is doing too much work, and especially he is doing the work of object creation. So if we can somehow remove this object creation of this data access layer from this customer object, right, or from the middle layer, then probably we would go towards a decoupled architecture. In other words, if this customer class just references the data access layer, and there is no reference of SQL Server data access layer or Oracle data access layer, then definitely we are moving towards some solution, right? So the first thing is, we should get rid of this object creation activity what this customer class is doing, because remember, this customer class or the middle layer is supposed to do validations, is supposed to do business logic, and not object creation, and not deciding that he has to create a SQL Server data access layer or a Oracle data access layer, right? So the first thing is, I would like to get rid of this object creation completely from here. So I'll do a delete here. So that's nice. Currently if you see this current situation, the customer class is just referencing this interface IDAL. So if you think from the customer class point of view, he has become selfish. He says that I will do just my work. That means he's trying to follow the solid principle, single responsibility principle, saying that I will do only one responsibility, that is business logic and validations. I'm not the guy who will decide data access layer, SQL Server data access layer, or Oracle data access layer. That has to be taken care by someone, right? So what we'll do here is we'll create a constructor and we'll say that somewhere from outside somebody will pass the iData access layer object. So you can see here what I'm doing is from the customer class perspective, I have become shellfish. So you can see here what I've done here is the customer class here is exposing out a constructor, and he says that someone else. Now who is that someone else? We have no idea of it, right? But the person who is going to go and instantiate me has to pass me that he wants to invoke me using the SQL Server data access layer, or he wants to invoke me using Oracle data access layer. In simple words, the creation of the data access layer object is now the responsibility of the caller who invokes the customer class. So for example, currently this customer class is getting invoked from this UI here, that is through our static void main. So it now becomes the responsibility of the UI to invoke the object. So you can see here, whoever invokes the customer object, he has to pass to him saying that, okay, this customer object has to be invoked using the data access layer, SQL Server data access layer, or it has to be invoked by using the Oracle data access layer. But still our dream of achieving that decoupled architecture is far away, because what has happened, with this exercise, what we have done now is we have just passed the bucks around actually. In other words, the object creation was first happening inside the customer class, is now happening inside the user interface. So really things have not changed. In other words, if I add a new data access layer, I have to now change the user interface code, right? But what I really want is, if I add a new data access layer, I don't have to change any one of these layers, right? And that's what a decoupled architecture would look like, right? So the only way to achieve this is by giving the object creation activity to some external third-party framework, a framework which is configurable, a framework which is easy to use. Because if we do this object creation activity inside our code, now that code can be either the middle layer or it can be either the user interface, then we would be just passing the bucks around and we would not be able to achieve our decoupling dream. Now there are a lot of frameworks out there which help you to do dependency injection. For example, we have Unity application block, which comes from the Microsoft patterns and practices. Then we have the managed extensibility framework MEF, which is a part of your .NET framework. We have Ninject, etc. But at this moment, I have chosen Unity application block because it's a lightweight component and it's been time tested for so many years. So I'm going to use Unity application block here to do dependency injection. Now, in order to reference the Unity application DLL, the one way is that you go to google.com, you search for Unity application DLLs, download them as a RAR format or the DLLs, download it in your folder, unzip the RAR, add the reference, etc. A lot of work, right? Or the other way is by using NuGet. In case you're new to NuGet, my suggestion is to go and watch the video of NuGet, what exactly it is and how it helps you to add references to the third-party DLLs. But at this moment, I will quickly go to the NuGet here. So I'm going to go to tools here. I'll click on tools. I'll click on this NuGet package manager and I'll say manage NuGet packages for solution. So you can see that, my NuGet has opened here. And what I've done is I have clicked on this search box here. I have typed Unity and you can see the first search on this Unity here. So on this Unity, I'm going to go and click on install. So I'm going to go and click on install here. You can see it is now installing. I'll say yes, okay. I accept the licenses. So you can see now what happens with NuGet is automatically the DLLs are downloaded. It adds the references to your project. Everything is automatic here. So rather than going and downloading, by using the traditional way, you can use NuGet here. It is much better. It's easier and Also it is more accurate as compared to doing things manually, right? So let me go to my Solution Explorer here, and you can see that on my Solution Explorer there are 3 DLLs added. You can see this Microsoft.practices.unity, you can see this Microsoft.practices.unity.configuration, and there is Microsoft.practices.unity.registration by convention. So these 3 DLLs are added over here. So we are all set. In other words, the DLLs are added. Now we have to go and write the code. Now before I move ahead and I write some code to do the injection, or before I start demonstrating some code using Unity, let me explain you what these 3 DLLs do. Microsoft.practices.unity and Microsoft.practices.unity.registration by convention, both of these DLLs actually do the injection. So they will actually create the SQL Server object and inject into iData access layer. They will actually create the Oracle object and inject into iData access layer. Now Unity also provides how do you say, a way out, where you can go and write your configurations into an XML file. Now that XML file can be app.config, it can be web.config, or you can also go and create your own XML file if you want. Okay, so in this XML file, probably you can define configurations like saying that, okay, inject SQL Server data access layer into IDAL interface, inject Oracle data access layer into IDAL interface, right? So such kind of configuration you can define into the XML file. To read that XML file, this DLL, that is Microsoft.practices.unity.configuration, will help you out. So Microsoft.practices.unity and registration by convention, they actually do the injection, and this unity.configuration reads from the XML file the configuration and applies it to your code. So let us go ahead and start writing code. So first thing first, we have to go and import the namespaces. So at this moment, I'm not going to go and write the configuration in an XML file. So I don't want that configuration, that unity.configuration reference, but I do want the reference to the Unity namespace. Why? Because at least I want to do the injection, right? So in the next part of the video, we'll see that how we can go and put the configuration into an XML file and then apply it to a project, right? Right, so you can see that I have imported the Microsoft.practices.unity namespace here. Now the next thing is I need to go and create an object of a container. Okay, so I need to do something like this. I'll say here iUnity container, obj container is equal to new Unity container. Okay, I'll explain you what exactly this container does. Let me just write the code and then I will explain you from the code itself, what this concept of container is. Now remember, Unity application block is a third-party framework. In other words, it is not a part of .NET framework, or it is not a part of your application, right, directly. So it has no idea what kind of classes your object has. So for example, Unity application block does not know that you have a customer class. It does not know that you have a SQL Server class or an Oracle data access layer class, right? So the first step is to make aware of your project classes to the Unity framework, and this is done via using the container. So what you need to do is you need to add all your classes to the container, and the Unity framework will look at the container and he can then figure out what kind of objects it can create on runtime. So you can think about this Unity container as a basket, a bucket, a container, whatever you want to name it, wherein you have to go and register your objects, and then when you say, okay, now I want this object, the Unity application block will go to the container, create that object and give it back to you. So let us go ahead and register our customer class. Let us go ahead and register our SQL Server data access layer. Let us go ahead and register our Oracle data access layer, right? So let us go ahead and register our objects inside this container. So to register the objects, you have to say obj container dot register. So you'll say, okay, what do you want to register? I want to register, first thing is a customer class. So you can see I have registered my customer class. I have made the Unity application block aware that I have a customer class. Now also let us go ahead and register Oracle object, or I'll say SQL Server object, right? The data access layer objects. Now remember, there are two kinds of classes or objects. I'll say one is your main class like customer. Okay, so when you register a customer class, actually there is no dependency injection happening on the customer class. But remember, when you are registering a SQL Server class, or when you are registering a Oracle class, that's what is actually going to get dependency injected. In other words, those are the dependent objects. So when you are registering objects, which are dependent on each other, on which the actual dependency injection is going to happen. You have to say here, okay, I want to inject into iData access layer. You can see there's a from here and a to. So into iData access layer, I want to inject an object of SQL Server data access layer. So you can see here, when you are registering the dependent objects, you have to tell, what is the interface and what is the concrete object which you want to inject. So in the same way, I'll say register type, again, iData access layer, and also I want to inject the Oracle data access layer, right? Now, once you have loaded, or I'll say you have registered the classes in the container, the Unity application block is now well aware of what kind of types your application has. So now at any given moment of time, it's either in the UI or it's either in your business layer or middle layer, I'll say, you can go and you can demand for objects. So to demand for objects, what you can do is you can call the resolve method. So what I can do now, I can say here something like this. I'll say here, okay, container. Remember, you have to go via the container. Okay, so you register the objects in the container, and if you want to get the objects, you have to again get from the container. So I'll say here resolve. So this resolve is like getting the object. So I'll say, okay, can you give me out a customer object? So now let me put a debug point here and let me go and run this console application. So I'm going to go and run this console application here in a debug mode. So you can see now I'm in a debug mode, my application has ran. So now, the first 3 or 4 lines of code has registered all our classes in the container. And when I say resolve, what it does is it actually creates a customer object. So when I do a resolve here, you can see that he has created a customer object, and inside the customer object, you can see this is my customer object, and you can see inside this customer object, he has injected Oracle data access layer. So you can see now automatically the injection is happening via the Unity application block. So now if you see this current situation, the injection is neither done by the console application, that is the UI. It is neither done by the middle layer. It is neither done by the data access layer. It is done by someone else. And remember that, this first 3 or 4 lines of code, you must be thinking that I have written in the user interface. You can take this code and you can write it anywhere else. So it does not have to be in the UI. Okay. So at this moment, yes, this code is in the UI, but it can be, on some startup event. For example, let's say if it is ASP.NET, then probably this code can go in the global.asx file. Let's say if it is WPF, then this code can go in app.xaml.cs. So this startup code can go anywhere. It is not necessary that it should be a part of the user interface. But at this moment, when you talk about console application, the startup always happens from the static void main, right? So that's why I put the code here. But in actual enterprise applications like WPF or ASP.NET, they always have their own startup event, and these kind of code actually can go in those startup events. They don't have to be a part of any user interface. Great. So if I continue ahead and if I do a F11, you will see that he's actually making a call to the data access layer of Oracle, right? And my code runs successfully. Okay, great. So now if you see this current architecture state, right, it is a decoupled architecture. Why? Because the user interface at this moment, it does not have to be aware of SQL Server data access layer and Oracle data access layer. Again, I'm repeating, a lot of people must be thinking that why this SQL Server DAL and Oracle DAL is written in the static void main. We can always go and take this code and put it somewhere else. Okay, and that somewhere else can be anywhere. Okay, it can be the global.asx start event. It can be your app.xaml. Application load event or whatever, right? So it does not have to be here. In the UI, I have to just say container.resolve and I have to resolve the class, and the injection will happen automatically. So if you see the current architecture state, it is now completely decoupled. If I add a new data access layer, my user interface, it does not have to be aware of that new data access layer. So now let me go and define dependency injection again. I know that, when I started this video, I talked about the definition of dependency injection, but at that time, I know that it was not so clear. And I wanted, you to walk through this whole roadmap, through this whole thought process of how right from interfaces, we have then used this ready-made framework to do dependency injection. So I wanted you to go through that whole exercise, and I think we have done it now. So now let me again go and define dependency injection so that you can understand it better. Okay, dependency injection is nothing but it's a technique. It's a technique by which we can go and inject dependent objects of a class. So for example, if you see in this example, we actually injected the data access layer object using the container or using the Unity application block, right? So what we did, we created the object of the Unity application block container. We said, okay, these are the objects, and the Unity container, whenever you say, okay, give me customer, he injected the Oracle data access layer object and he gave it out to you, right? So again, I'm repeating, dependency injection is nothing but it's a technique, by which we can go and inject dependent objects of a class, and by doing so, we are able to achieve decoupled architecture, right? So in other words, when you say decoupled architecture, when you make change at one place, you don't have to go and change all over the places. So for example, in this case, when I added a new data access layer, if I add a new data access layer now, I don't have to make any kind of code changes, on my UI, right? Now there are a couple of unanswered questions here, right? For example, when we ran the application, right, it injected the Oracle data access layer automatically inside the customer object. So if you remember, right, when we actually ran this application, now remember that we had registered both the objects. We had registered SQL Server as well. We had registered Oracle as well. But what happened is, he injected the Oracle data access layer. So why did it happen? Why didn't he inject SQL Server data access layer? Remember, whatever is the last object inside your container, he has automatically taken that class. So whatever is the last registered object of that type, he takes up that object. So for example, if I go and paste it here, you will see now the SQL Server data access layer is the last registered object for the IDAL type, right? So what it will do in this case is he will actually go and inject the SQL Server data access layer object. So if you see now in your OBJ, you will see that he has injected the SQL Server data access layer object. Now this is not what we want, right? We want to specify conditions. We want to do a conditional resolve. In other words, I should tell him, from the console application saying that, okay, now I want a combination of customer plus Oracle data access layer, or I want a combination of customer plus SQL Server data access layer. So how do I go about doing that? So the first thing is we need to go and register both of these data access layer with some key. So what I'll do is I'll go and register this Oracle data access layer with the name Oracle and the SQL Server data access layer with the name SQL Server. Now we need to go and create two types of customer registrations. One is customer registration with the Oracle data access layer, and the other one is customer registration with the SQL Server data access layer. So let us first register customer with the Oracle data access layer. So in order to do that, I have to do something like this. I'll say here, okay, create a customer object, and in the constructor inject Oracle data access layer. Okay, and ensure that you are using Oracle. Okay, so you can see now I have created a combination of customer and Oracle data access layer. Actually this is IDAL. Okay, so you can see here what I'm doing is I'm saying, okay, create a combination of customer and Oracle, right? So you can see here this is customer plus Oracle, and this Oracle is nothing but it's a key which points towards the Oracle DAL class. And also I'll give a key name here. I'll say this is cust plus Oracle, right? And in the same way, let me copy this and let me create one more entry with SQL Server. So this is cust with SQL, and here I'm going to go and inject the SQL Server object. So you can see now I have cust Ora. Okay, I have cust Ora, which actually creates a combination of customer with the Oracle object inserted inside it, and I have cust SQL, wherein inside the customer object SQL Server data access layer object will be injected. So now let's say I want to go and create an object of cust Ora. That means the object of customer with the Oracle object injected inside it, I have to just say here obj container.resolve, and I have to just give the key name here. Okay, and if I just go and debug this, let's see what happens. So there it goes. We debug, and you can see that I have the customer object, and inside this you can see that he has injected the Oracle data access layer. Now if I go and use this cust SQL, so let's say I do a control C and I do a control V here. Now let's see what kind of object is injected. So again, I'm running the project in a debug mode. If I go to the object, you can see now SQL Server data access layer object has been injected. So you can see now how we are doing conditional dependency injection, or I'll say this is conditional resolve. So to do a conditional resolve, you have to go and register the type with some key name, right? And then you can use those key names to do a resolve. So now we are in a good shape. We can do normal injection as well as we can do conditional based injection. But now let us carry this decoupling fever one step ahead. How about moving these dependency registrations, what we are doing, into a XML file, and then loading the Unity container from that XML config file rather than loading it from this code like this. Now this is how a Unity application block configuration file looks like. Now this file is a very standard file. The file what you see here, you have to write it as it is. And if you don't want to type this file out, what you can do is you can just go and search on Google saying Unity application block configuration file. You should actually get this file structure, right? So in this file structure, the most important XML statement is this, okay, which says that you want to insert SQL Server object into the iData access layer interface. Okay, so this IDAL, in this IDAL, I'm going to go and insert SQL Server data access layer. So if you see here, our class name is SQL Server DAL, okay, not SQL Server. So I'm going to say here inject the SQL Server DAL object inside this IDAL, and remember that all of these interfaces and classes, they belong to the customer UI namespace. So you can see this this customer UI dot, this actually stands for the namespace, right? So that's a very typical Unity application block configuration file. You have to remember this XML statement register. So type, saying which is the type and what you want to map to, or what you want to inject into that. Now the next step is to load this configuration into the Unity container. So what we'll do is, first step, we don't need this code anymore. So I'm going to go and comment this code out. So this code is not needed. The first step is, if you remember, I said there are two types of DLLs which are loaded, when we actually use the NuGet package, right? One is the Microsoft practices.unity and the registration by convention. Both of these DLLs actually do the injection, and we had one DLL which actually reads the configuration. So the first thing is we have to go and import this namespace here. So I'm going to say here using Microsoft.practices.unity.configuration. Now this Microsoft.practices.unity.configuration only parses the config section of Unity file, right? So it only helps to parse the Unity file, but to load the app.config file, we still need our system.configuration namespace of .NET, right? So also let us go ahead and ensure that we have the system.configuration namespace, because the system.configuration namespace has all those DLLs or all those classes, which will help us to read the app config file, right? So once we are done with that, the final thing is we have to go and say obj container.load configuration. So what this method does is it actually loads the configuration from the app.config file. Okay, loads from app.config. Great. Config. Great. Now you can see that there is some exception there. I'll just move my mouse here. It says that this system.configuration is not referenced. So we also need to go and add a reference also. So let me go and add a reference. So I'll go here, I'll add a reference to the system.configuration DLL. So let me go to assemblies and I'll search for this word config. So there it is. So let us go and add reference to this DLL as well. This is the base .NET DLL. Actually, it's a DLL which belongs to the .NET framework. So let me build this. No errors. That is good. Let me put a debug point here. So at this moment, what we have done is we have said that we have to inject the SQL Server data access layer object into the IDAL interface, right? So let me go and start this program. So there it goes. The program starts. And now there the program is running. We have done one mistake. This cust SQL exists no more, right? Because this cust SQL, this string was actually belonging to the previous, conditional resolve what we did, right? So we have to remove this cust SQL. At this moment, this config file, does not do custom resolve, or I'll say conditional resolve at this moment. Okay, so there is no conditional resolve. It's just a basic resolve, the basic resolve what we did previously. So it's going to just go and inject this object into the IDAL interface, right? So let me go and again run this. So there my application runs. I'm in a debug mode. And if I now go and see in the OBJ, you can see that he has inserted the SQL Server data access layer object. Great. So I hope that you have enjoyed this video. In this video, we discussed the need of DI, that is dependency injection, how we can do DI using Unity application block. We also saw how we can do conditional resolve. And finally, we saw that how we can load these configuration into the container from an XML file. So I hope that you enjoyed this complete 40-50 minute series, and I hope that you can now create decoupled architecture using Unity application block. Thank you so much. Enjoy your decoupled architecture. Thank you.